Welcome to lecture 21. In this lecture, we're going to be talking about a few strategies for solving problems on caches, and we'll also look at a few sample problems. So before I do that, let me briefly recap three cache designs that we went through in the last few lectures. So the first one is a fully associative cache. In this cache design, a given cache block can be stored in any one of the cache lines in the cache. So for example, in this picture, I have 4 cache lines, and a blue cache block can be stored in any of those 4 cache lines. Now the downside of this is that I need to do a lot of tag comparisons. So if I have 4 cache lines, then to look up any given address, I need to perform 4 tag comparisons to figure out if that address is present in the cache or not, meaning if it is a cache hit or not. The upside is, of course, that because I have this luxury to store a cache block anywhere I want, generally a fully associative cache would give you a higher cache hit rate compared to the direct mapped cache and the set associative caches. So the direct mapped cache is the most restrictive in terms of where you can store a cache line. It gives you exactly one choice. So in this example, I have 4 cache lines. Each of them is part of a different cache set. Each cache set in a direct mapped cache has exactly one cache line. So in the direct mapped cache, a given cache block can be stored in exactly one cache line, and that can often lead to a lot of conflict cache misses, because now several cache blocks that map to the same cache line can compete with each other. As a result, they can kick each other out of the cache, leading to a number of conflict misses. So in this example, the orange cache block can be only stored in the orange cache line. The blue can be stored only in the blue cache line. The pink can be stored only in the pink cache line, and so on. Now, the number of bits that you need for selecting which block to store a given cache block depends on how many cache lines you have. Another way to think about it is each cache line is really part of a set, and the line index or the set index is selecting which set to store that cache block in. Again, a set in a direct mapped cache has exactly one cache line. Okay. In the case of a set associative cache, a set contains as many cache lines as the number of ways. So for example, in the case of a 2-way set associative cache, then each set has 2 cache lines, like I'm showing here in this picture. So what I'm showing here is a 2-way set associative cache. So I have way 0 and way 1, and they both are part of the same set, which means a given cache block that maps to a set can be stored either in way 0 or way 1. So I have 2 choices now. As a result, I can have a better cache hit rate than a direct mapped cache, because this 2-way set associative cache would eliminate some of the conflict misses that you would endure in a direct mapped cache. Now the set index is again going to be determined by how many sets you have. The only difference now is the number of cache lines within a set is different.